Hi, my name is Nicholas Wagner, and I am the math instructional coach for the Barney Charter School Initiative. Today we're going to be talking about the use of the base 10 blocks. And before we jump into the actual use of the manipulatives, I wanted to highlight that in Singapore math, there are really three phases for place value development. The first is building and renaming numbers. So you're going to build and rename the numbers. Then you're going to change or rename and regroup numbers. So renaming, regrouping. And then lastly, you're going to build the four standard algorithms. The standard algorithms, that if you don't know what standard algorithms are, that would be the vertical addition. So 159 plus 464, where you're adding vertically and you're quote unquote carrying. We're not going to use that language. Then we have the vertical subtraction, 215, for example, minus 136. Then multiplication would also be vertical, 245 times 3. And then the long division is going to be your fourth standard algorithm. So those are the examples of your standard algorithms that you're building to. Now, for Singapore math, they don't start the standard algorithms until the second grade. In the second grade is when they do the addition and subtraction. And then in third grade is when they really hone in on the multiplication and division standard algorithms. So oftentimes your parents are going to want to teach them the standard algorithm. I ask that you ask them to hold off on teaching that to their kids, your students, until after you've already gotten there and taught that. The reason behind this is that you really want to focus on the development of the understanding, the concept, before they go into the algorithm itself. So you want them to understand addition, you want them to understand long division before they actually, division before they actually get to those algorithms, including long division. So let's do a few problems that are more straightforward, no renaming, no regrouping. So we'll start with addition. The way that you're going to do this is you're going to have a place value mat, your ones, tens, and hundreds. And you're going to start by saying, somebody read that aloud to me. And you'll hear 123. And you say, stop. Great, thank you. Let's build that. What is 123? And you should be listening for something like, that is 100, 2 tens, and 3 ones. By the time you get to this point, they should know what that means. They should know that 123 is the same thing as 100, 2 tens, and 3 ones. And they say, keep going. OK, great. So they say 123 plus. You say, stop. Then you ask them, what is addition? What do you mean plus? Explain that. So every step of the way, you're asking them to explain it. You're pulling it out of them. So they're going to say, well, it's combining or bringing together. And so then you say, OK, what am I adding to this? What am I bringing together with 123? And they say, 452. And then you ask, well, build that. You say, build it or name it. Show me 452. So then they say 4 hundreds. Then you have 5 tens. And and 2 1s. Okay, and again, we're not renaming, we're not regrouping this one, so they should be understanding that now we're going to combine these. I have 3 and 2 makes 5. 3 plus 2 is 5. 2 plus 5 is 7. And 4 hundreds plus 100 is 5 hundreds. So I should have 5 hundreds, 7 tens, and 5 ones, or 575. Okay? That is without regrouping. Let's go ahead and do subtraction. Let's do 359 minus 126. My apologies. In the last one, I wrote it in the standard algorithm form. Before you see this, I should make a note that it's not going to be written vertically, but horizontally. And the reason it's written horizontally in your book is that they're wanting to get in the habit, they're wanting students to get in the habit of making those number bonds. So for a long time, they're going to be written horizontally and not vertically. So 359 minus 126. Let's take these off so as to not confuse. And the first thing you're going to do is say, somebody read the problem. And so they're going to read the problem. Forgive me. There we go. You're going to read the problem. 359. You say, stop. Let's build that. What is 359? It's 3 hundreds, 5 tens, and 9 ones. And I want you to notice the way that I'm placing my ones would be in line with a 10 frame. So 5 across the top, and then there would be another row. 9 would only fill up 4 of those spaces in a 10 frame. Okay, so we have 359. And so the question is, you keep reading and you say 359 minus, and you say, what does that mean? And they should be saying, take it away. And so you say, okay, take away what? 126. Great, 126. I'm taking away. So I'm going to build it, right? Again, the leading question with the wrong answer, you say, no. They should say, no, you don't build it. You take it away from the quantity that's there. So then you say, okay, so how many do I have to take away in the ones place? I have to take away 6. That's right. So I take away 6. Okay, and then how many ones am I left with? 3. Now I go to my tens. How many am I taking away from 5 tens? I'm taking away 2 tens. Great. So how many tens do I have left? I should have 3. 3 tens. So far I have 3 tens and 3 ones. And I'm taking away how many hundreds? I'm taking away 100. Okay, good. So now I have 2 hundreds. So 233 would be my solution. Okay. So again, not carrying, not regrouping, not renaming. Very simple, straightforward problem. And notice I'm setting these aside over here so that I can then check, did I take away 100, 2 tens, and 6 ones? Yes, I did. And now I have that left over here. Okay. So let's do a multiplication problem. Without regrouping or renaming, which, by the way, the language of instruction does matter. You want to say rename or regroup as opposed to carry or borrow. you're wanting to, a good phrase that I like to use is trade in for, because students know through their years of experience with cards like Pokemon or some other card game that they have to get equivalent values. They know that they're not going to get ripped off, so they want to trade something equivalent with what they have already. So let's go ahead and do another simple problem. 232 times 2. So you're going to walk through it again. You have ask them to build it. Say they read it aloud. 232. You say stop. You have 2 hundreds. You have 3 tens. And 2 ones. And then you ask them, what is multiplication? They're going to say, some may say it's repeated addition, or it's multiples of what you have already there. So you say, okay, so what do I need to do to 232? I have to build it again. I have to build there should be 2 sets of them. So 232. Okay. And so now I should be good to go ahead and combine them. So I have 2. Again, I did this wrong. It should be 232 times 2, horizontal. Don't get them in the habit of the vertical until they're ready for it. So 2 and 2 make 4. And then I should have 6 here. And then I should have 4 here. 464. Okay. And now for a division problem. We can do 482 divided by 2. So I should have 4 hundreds and then I should have 8 tens. And 2 ones. And I'm dividing it by 2. So I ask them, what is division? And a lot of them are going to say splitting into groups. And you want them to refine their explanation. So when they say splitting into groups, you should say, I need more. I need more. Please tell me more. What's wrong with just splitting it into groups? If I split it into groups, you can say, OK, so this works, and then this is a group, and then I have these here. And that's a group, and then there's nothing in this group. And they're going to realize, no, division should be equal groups. So in this problem, I'm going to have 2 equal groups that I'm separating these quantities into. So I'm going to mark my board into 2 equal groups. OK? So I'm going to start with my hundreds, and I say, how many am I going to put in each group? Well, they should recognize from their math facts that 4 is 2 groups of 2. But when you ask them the question, and they say 2 belong in each group, you should say, how do you know? Tell me, explain. Why is it that 2 should be in each group? Not just because they're equal, but why 2 and not 3? Why shouldn't it be 3 in each group, or 3 in one group and 1 in the other? And then they get to the tens, and they're going to say that 4 should be in each group. How do you know? Ask them that over and over again. Make the students explain. Draw out that explanation. And then how many should be in each of the groups for the ones? There should be 1 in each group. So then you say, how many groups of 2 are there can you make in 482? Or rather, if you divide 482 into 2 equal groups, how many are in each group? So that's the difference between partitive and quotative division, what I just did there. So you can say 241 is in each group. 241. Okay, so I've gone through the problems without renaming, regrouping, or trading in. Now I'm going to do a couple where I have to regroup. And if you'll bear with me, I believe that it's worth seeing them for each of the types of problems, each of the 4 operations. Okay, so let's start with 159 plus 464. And now I'm going to walk through this. I'm going to walk through this with the standard algorithm. So by this time, they're developing the standard algorithm, and they should know what that is. They should, well, sorry, not know what that is necessarily, but they should be learning what the standard algorithm is, so you're not afraid to be using it right now because it is the appropriate time. So we have 159. You ask the students to build it. Sorry, 100, 5 tens, and 9 ones. And then you're adding or combining 4 hundreds. So this is the second number. 6 tens. Ooh, good, I have some. And 4 ones. Okay. So it's important here, when you combine them, what you're wanting to show them is 9 plus 4, or 9 ones and 4 ones makes 13 ones. But I can't write a 13 here without running into the tens place. So what I have to do is I have to regroup or trade. So I have to make a group of 10. I'm going to take this one here, make that group of 10, and I'm going to trade that group of 10 with 10 ones with 1 10. I think it's helpful for some students when you initially are doing this to line up the 1 10 with the 10 ones so that they see that those are equivalent. Again, they're used to trading, and they will recognize if you're trying to rip them off. So those are equivalent. My bars, my manipulatives are a little bit warped, so it's not as obvious. But now I have, instead of those 10 ones, I have 1 10. I'm going to take that 1 10, and I'm going to put it here. So I'm taking 1 10 and putting it here. These are going off to the side. And how many ones do I have left? I have 3 ones left. So I had 13 ones. I made a group of 10 ones to trade for a 10. And I traded that, and I moved that 1 10, the 10 ones, change into a 1 10 over to the tens place. Now I'm going to do a similar thing with my tens. So I'm going to group my tens into a group of 10 tens. Okay? Because I realize that 5 plus 6 plus 1 is more than I can put here. It's going to be 12. I have 12 tens. I recognize that. So I'm going to make a group of 10 tens. 2 will be left. And I'm going to trade these 10 tens for 1 100. Again, you can put those next to each other so they see that the values are equal. I'm going to take these and move them out of my 10 frame. I'm going to take this 100. And I like to draw the arrow to show I've moved this over. And that arrow aligns with drawing that 1 right there. So I'm moving, if I can redo this, I'm going to move this 100 there. So now I have 2 10s left. I still have the 3 1s, and now I'm to my hundreds. And I have 1, 2, 3, 4, 5, 6 hundreds, which lines up with my 4 plus 1 plus the 10 tens that we traded as 100, which is 623. So there's the addition for you with renaming and regrouping. Next, we are going to do, I'm going to go ahead and skip the subtraction and the multiplication and jump to the division. If you would like to see a sample of the subtraction and multiplication, which you're going to do something very similar to what you did with this problem, I have on Box a PowerPoint with manipulatives already listed on there, already shown, and you just have to click through the animations to see those step-by-step drawn out. For the division, let's go ahead and do 706 divided by 3. So you're going to start by asking them to build it. 706. So that's 700, 700s, and 6 ones. Oops. All right. And so now I have 706. And recall, you're going to get them to explain that it's separating these into equal groups, specifically 3 equal groups. So I'm going to mark on your board that you have group 1, group 2, and then group 3 down here. Let's see. Okay. So I'm going to ask them how many of these can fit into each group equally, and they're going to tell you 2. Again, use this time to ask them lots of questions. How do you know it's 2? Why is it 2? Things like that. And you say, oh, no, can I just put this here? And they say, no. And you say, why not? And they'll say something to the effect of, now they're not equal. So I ask them, what do I do with that 100? And what I do with that 100, they should know, is this 100 is equal to 10 tens. So I'm going to trade this 100 for 10 tens. So I'm going to take this. Let me make sure that I am following my sequence here. Go back for a minute. I had 706 divided by 3. I'm doing again the standard algorithm. So I moved 2 into each group, and therefore I am using 6. And how many do I have left? I have 1 left. That cannot be split into those groups equally. Okay. So let's go back here. Now I'm trading the 10. Ooh, that's a terrible noise. The 10 tens for 100, or rather the 100 for 10 tens. I'm going to set that aside. I'm going to move these over here. And I'm going to draw this arrow again. I traded the 100, so this is my 100. It's not there anymore. It's now 10 tens. And notice, how many tens were there before I moved those 10 tens over? There were 0. Well, that's what this is here. It's a 0. So now I have 10 tens, and this line starts to make a whole lot more sense. By the way, some people use the place value notation above the problem, so that they can see that those place values matter in the long division. So now I have 10 tens. How many of these tens go into each group? I have 3 groups of 3. You can ask them, why is it not 4? How did you know it's 3 instead of 4? And they say, well, 4 times 3 is 12. Well, why do you multiply by 3? Get them to explain it over and over again. So I have 3 in each group. And so I've used 3 groups of 3, which means I've used 9. And I take away the 9 from the 10, and I'm left with 1 10. Now, can I use that? Can I put that 1 in these others? No. So my students quickly realize that I need to trade that 10 and for 10 ones. Ooh, and it looks like I might be 1 short. Oh, it fell. Here we go. Okay, so I trade that in. Now I'm going to move this over here. I can, if this helps, you can draw it on the board and cross it out. So they see that. And so I'm going to take these 10 ones, and I'm going to move these 10 ones over here. Okay. And so how many ones do I have now? How many did I have there to begin with? Sorry. I had 6 to begin with. And now how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. Yes, I just counted for you. I had 1 10, and there were 6 ones there already, so I should have 16. I should have 16. That makes sense. This, and I take this, and I say I changed it in for 10 ones. So then how many are going to go in each group? You say 5 in each group. And it should be noted that for a time, you might use the concept of remainder as R. So you've used 3 groups of 5, which is 15. How many did you have left in your ones? You had 1 left. So you have 235, remainder 1. And you have solved that problem using the manipulatives alongside the standard algorithm. So they see in each group 200, 200s, 3 10s, and 5 1s. So you can either visualize this as 3 groups of 235, or you can say that there are 235 groups of 3 in 706. Okay, so those are the addition and long division algorithms. Again, you can check out the subtraction and the multiplication algorithms on our box link. If you don't have that, please feel free to email me at nwagner@hillsdale.edu. Thank you very much.